Hi, everyone. I'm Rick Weiss, Director of SciLine. Welcome to this latest media briefing on lead contamination of drinking water. I want to take 1 minute to quickly introduce everyone to the nature of SciLine. For those of you who haven't joined us on one of these briefings before or used our services, we are a philanthropically funded free service for reporters that's geared towards helping you get more scientific information, research results, and evidence-based context into your news stories. We help science reporters, we help general assignment, we help local reporters, anyone whose stories would benefit by getting a little more evidence and scientific results into your stories. And I think that that pretty much means everyone in every kind of story, since our bias here is that every story is better with a little bit of science and evidence in it. So I want to quickly review the 4 features that we offer you through SciLine. We have our matching service, which many of you are familiar with. You can send us a quick email, tell us what your story is about, what your deadline is, and we have a large database of scientists who are excellent in their field and who are great communicators who we can connect you with on deadline or as needed. We also produced fact sheets on various topics in the news that are very succinct and designed for use by harried reporters who just need some facts in a hurry. They are produced in-house and vetted by a half a dozen or so outside experts in each case, so you can really rely on them and trust them. We do these media briefings, which you'll get a taste of right now, and we're doing boot camps around the country where we take 25 or 30 reporters at a time on an all expenses paid 2.5-day training camp to get you up to speed on various topics, and you should check out our website, sciline.org, to find out more about those. So today we're focusing on lead contamination in drinking water. It's a timely time to do it. Last month was the 5-year anniversary of the beginning of the now famous or infamous Flint water crisis, when officials in Flint switched the water supply source and led their community to be exposed to toxic levels of lead for many months, actually. Lead, we all know, is an insidious poison. Scientists tell us there is no such thing as a safe level. But progress to minimize exposures have, although they've been made, progress has been slow, in part because of our extremely decentralized network of water providers, which you'll hear a little bit about today, and in part because of years of regulatory delays or failings along the way, which you'll also hear about a little bit today. Today's media briefing will get you up to speed on these topics. We've got 3 very knowledgeable people to lead the discussion on this. I'm not going to go into their full bios right now because those are available on our media briefings landing page at sciline.org. But very briefly, in the order in which you'll hear from them, Dr. Adrian Kattner of Louisiana State University Health Sciences Center, whose research, which focuses on lead exposure and risk assessment, has resulted in statewide policy changes on home testing for lead in water. Dr. Mary Jean Brown of Harvard's Chan School of Public Health is an expert in childhood lead poisoning, formerly with the CDC, and who now continues to work with federal and international health agencies on the lead issue. And Dr. Jackie McDonald Gibson of the University of North Carolina, who brings to this discussion not just 1, but 2 PhDs in engineering and public policy and in civil and environmental engineering, and whose research focuses on the quantification of environmental risks in US communities, has done some very interesting research in some US communities, and looks at policy options for reducing those risks. So without further delay, let me turn it over to Dr. Adrian Kattner to get us started.
Hi guys, thanks for inviting me today. I'm going to go pretty quick so we can have more time for questions. But humans have been using lead pipes for drinking water for thousands of years. But it's recently become a global problem because of the use of leaded plumbing, using lead pipes for service lines especially. That's the line in the street from the main to the meter to the home was a common practice because it's so strong and it's resistant to subsidence. Service lines can be the biggest contributor to lead in water, but it wasn't until about 1986 that we finally banned it. But even homes with no lead service lines can still have lead in their drinking water. Other sources include water in galvanized iron, ductile iron mains, water meters. The total number of homes that have leaded plumbing is unknown, but the risk is considered pretty widespread. The risk poses is of concern in part due to the significant irreversible health effects of low-level lead exposure, which Dr. Brown will talk more about, but also the inherent difficulty of regulating lead in water. The EPA's lead and copper rule, or LCR, was implemented in 1991. To give you a little bit of information about it, the purpose was to reduce lead levels in tap water. And it was the first rule of its kind because it actually required sampling at the tap in customers' homes. And this was essential because lead is primarily picked up from water distribution systems and premise plumbing. Specifically, the lead and copper rule outlines corrosion control and how utilities will sample and report lead water results. It requires that utilities collect a first draw tap water sample from high-risk homes, and that includes homes with lead service lines. That's one of the first issues with the lead and copper rule, because first draw samples are generally lower than flush samples because they're more indicative of lead that's in premise plumbing rather than lead from service lines. And we have found that to be true in New Orleans in particular. So it takes that amount of time for the lead that's in that service line overnight to reach the tap. So about 30-second to a minute flush, depending on how long your service line is, that's how long it may take for that lead to reach the tap. Next, the lead and copper rule requires that utilities report the 90th percentile water lead level from their sampling to the state. The state will then compare that level to the drinking water lead action level, it's called, of 15 micrograms or per liter, or ppb. If that 90th percentile exceeds 15, the utility does not meet the action level. So put it another way, if more than 10% of a utility's samples exceed 15, then it is out of compliance. And then the utility has to adjust their corrosion control. And when that fails, they may also have to take out lead service lines out of 7% of the homes in the town that every year until they come back into compliance. Next, this regulation is not protective of public health because, again, if 10% of homes are below the action level, then the utility will meet the regulations, even if some of the samples have hazardous waste levels of lead. The EPA emphasized at the time that this LCR, the lead and copper rule, was set with an action level as a screening tool to evaluate the worst and to identify the worst communities. It was not meant to be confused with a health-based standard. The EPA does have a health-based standard for lead in water. The maximum contaminant level goal is unenforceable, and that is 0. So it's not surprising that the EPA has acknowledged that compliance with the lead and copper rule does not guarantee or even imply that all individuals in the city are protected from lead hazards. Next. Next. So let's quickly take a look at what I found in New Orleans. We sampled about 400 homes here, regular use homes. We collected water and we compared them here on this chart to various water standards. I'll walk you through them. Next. The first standard is the EPA's action level, which we just talked about. So New Orleans is compliant with the lead and copper rule because only about 7% or less, less than 10% exceeded the 15 parts per billion action level. Next. A lot of states are trying to set their own action level that is more strict than 15. Several of them are turning to the World Health Organization's level of 10 parts per billion, but they recently put out an informational saying and emphasizing that this was really based on analytical achievability. The cost of the equipment necessary to test the water at levels lower than that can be cost prohibitive for some developing nations. So it's not strictly a health-based standard. The FDA standard of 5 parts per billion is a lot more conservative than the EPA's. And that's because a lot of bottled water simply doesn't have lead because it's really brought in by the distribution system that it has to go through, and bottled water wouldn't have that issue. Next. So the first, the million-dollar question is really what is the amount of lead in water that would be a problem? And we don't have a really good handle on that. But I will tell you that in 2016, the American Academy of Pediatrics recommended that schools reduce their water lead levels to below 1 part per billion. About 73% of the New Orleans homes that we sampled exceeded that amount. So there's much we don't know about the long-term accumulation of chronic exposure to low-dose lead. One study by Noida et al. In 2015 estimated that water lead levels at this level of 1 ppb could result in some amount of blood level increase over a long period of exposure. Now, the 2009, the Cali PA did propose a public health goal of lead in water. This is just a recommendation. It's probably the most recently developed health-based standard, but it's just a goal. But it is based on more recent science about the neurodevelopmental health effects of lead in infants. And it is 0.2 parts per billion. This is really hard to get down to, especially if you have a town with lead service lines. Even if you don't have lead service lines, you can have lead in other plumbing fixtures. It's also difficult for some labs to detect at water levels that low. Most labs will report levels, they don't report at less than 1 part per billion because there's greater error. In New Orleans, about 97% of the homes that we sampled exceeded 0.2 parts per billion. So this suggests that a large proportion of the city's population, particularly pregnant women and families with children, may be at potential risk if they drink unfiltered tap water on a regular basis. Despite potential health implications, which will vary by individual and particularly impact vulnerable populations like children who can absorb more lead than adults, the city would still be considered LCR compliant. And I think this is the issue that Flint is facing now. They are compliant, but what we know about the lead and copper rule and its limitations beg us to ask, is it still safe? And it's next. While we do find in New Orleans, even though we are compliant, we did find lead levels as high as 50 parts per billion in a single resident home, over 200 parts per billion in a home that had line replacements done recently. So we can get these large doses that you see up here on the screen that can pack up a big punch and can get through that aerator screen. Next. So the way the sample is collected can impact water lead level results. And some of the ways that they do this is pre-flushing water prior to letting it stagnate, removing the aerator, collecting water at low flow. All of these things are legal, but they are widely used by utilities to artificially get lower water lead levels to meet regulatory compliance. Next. In 2006, the Government Accountability Office alerted officials that we need to update this lead and copper rule. Next. But to date, the lead and copper rule remains largely the same. Policies continue to focus on water testing, may not be a good approach. Public health officials are saying we need to use primary prevention. By that we mean we need to reduce their exposures. And so resources probably would be better used on actually filtering out the lead. We have a lot of low-cost point-of-use filters now that low-income communities can afford and that are doing a really good job. Right now we're doing a field study with HUD looking at and doing experiments to find the best filters and also to experiment with them in the field and make sure that they're going to be working. So I will turn it over to the next speaker.
Great, thank you very much. And Dr. Mary Jean Brown from Harvard.
Hello, everybody. Thank you for being here. Next slide. So basically, we have been unable to identify a safe blood lead level in children. And as you can tell by looking at this slide, the higher the blood lead level gets, the more severe the symptoms and the more severe the outcomes. So blood lead levels above 40 are very unusual in children in the United States now. Internationally, unfortunately, that's not the case. And below about 30 or 20 micrograms per deciliter of lead in blood, children don't exhibit any overt symptoms that are easy to distinguish from other conditions. So most children who have high blood lead levels are between the ages of 18 months and 2 years. And if they have symptoms, it's that they're cranky, tired, and not eating properly. So if you've spent any time with a 2-year-old, you will know that that is not an unusual condition for 2-year-olds. So we use blood lead level to give us a peek at what the child's intake of lead has been. And it's an integrated average, not only of what's coming into that child at the time of the test, but lead is stored in soft tissue and bone. And so it also gives us a little bit of an indication of what's going on in the other tissues. But at blood lead levels well below 10 and even below 5, we do see that some children will have decreased IQ, decreased hearing, and behavioral problems. And these lead to deficiencies later in life. So children who have had high blood lead levels are less likely to do well in school. They're more likely to have problems controlling their impulses and therefore often come to the attention of the juvenile justice system. But these blood lead levels are not predictive for an individual child either. So we have to be very careful about how we talk to parents whose children have blood lead levels of 6 or 12. I can tell you that if I have 2 kindergarten classrooms and everybody in the kindergarten A had a blood lead level of 5 micrograms per deciliter or higher when he or she was 2, and everybody in classroom B did not, I can tell you that the children in classroom B are going to be doing better in school than the children in classroom A. But I can't tell you that Mikey's not going to MIT just because he's in classroom A. So there are many things that people can do to support their children's intellectual development, and some of these seem to have some impact in terms of how children look on the other end. So how do kids, next slide, please. So let's think about how children get exposed to lead. So we've done a really good job of spreading lead all over the world. So we have lead in paint and in industrial and gasoline emissions. So lead in gasoline was pretty much banned in the United States in the late 1980s, and the worldwide ban has gone into effect, with only Afghanistan now continuing to have leaded gasoline. But the emissions that were there, that came out, are still there. Lead gets into water, usually as part of the plumbing system. It's not the water that comes out of the wellhead. It's as the water transverses through the system. And there are various things that we can do to try to reduce blood lead levels and to try to make the health outcome much better. The most efficient way is to prevent the exposure in the first place. So this model here shows various ways that you can limit children's access to lead. Safely removing lead paint hazards is probably number 1. Number 2 is to enhance the corrosion control and water treatment so that so lead is less likely to leach into the water system. And I mean, these are engineering controls. A parent may not have any control over that, either of those things. The other things are less efficient, and also they have to be done a lot. So, it's a really good idea to wash 2-year-olds' hands before they eat for many reasons, and lead is one of them. A good diet seems to decrease the intake of lead through the GI tract. There are various medicines that come under the title of chelation therapy that can be used to reduce blood lead level, but none of these reduce any of the adverse health outcomes that existed when the blood lead level was high. So we cannot reverse any damage that's been done, although we can prevent further damage. And then finally, intellectual stimulation and good early childhood education holds some promise, but it certainly needs to have more research for us to be able to understand how best to provide it to children. Next slide, please. So there are tremendous health benefits. This is from a recent report by the Pew Charitable Foundation, and talked about how if we eradicated lead paint hazards from older homes, that would provide $3.5 billion in future benefits, mostly for the productivity of these children as, over time they'll get better jobs, etc. Excuse me. Next slide. Yeah. So removing lead in drinking water is also has a big yield in terms of its return on investment. I mean, 30 to 35 cents per dollar invested it's almost a 40% return. And I know your stocks are not making that right now. Next slide, please. So also we need to ensure that contractors comply with the EPA rule that requires lead safe renovation and repair. So this is what happens to middle class and affluent families. If you hire somebody to work in a house that was built before 1978 and is going to disturb the paint, basically the law says he has to clean up after himself. And then finally, the last one, airplane fuel for those small piston engines airplanes still has lead in it, and that is also contributing to children's blood lead levels. So what we're recommending with the Pew report and other public health reports and experience tells us we need to take a holistic approach to lead for children. If we can't find a safe blood lead level, the only response is primary prevention, and primary prevention requires that we control or eliminate sources of lead in children's environments before they're exposed. And it is a mistake to put different sources of lead in competition with each other. We need to make sure that we reduce the lead in the water and we take care of the lead paint hazards, and we do something about avgas, which is the airplane gasoline. Thank you.
Great, thank you, Dr. Brown. And Dr. Jackie McDonald-Gibson, you're up.
I am going to talk about a different population that's being exposed to lead that's perhaps very under-recognized, and that is that I'm going to talk about households that get their water from unregulated private wells.
Oh, God.
So the residents of Flint, Michigan, and also New Orleans get their water from regulated community water supplies, and those regulated community water supplies are supposed to follow the lead and copper rule and use the corrosion inhibitors, add corrosion inhibitors to the water to prevent lead from leaching. And, you know, Flint was a good example of what goes wrong when that process breaks down. But nonetheless, residents of Flint, you know, the utility there is supposed to take these measures, is required to test water. So, but about 14% of the population of the US, or about 45 million people, gets their water from private wells that aren't regulated. And these are wells that serve fewer than 15 households or 25 people year-round. So they're completely unregulated. And there's evidence that these households are at increased risk of exposure to lead in their water, really for the same reason that, a similar reason that some of the problems occurred in Flint, which was the failure to control the risk of corrosion in water. So most people who have a private well don't know that they need to test their well, or they may know, but they may not ever get around to it and may not even be aware of the risks. Lead can't be seen, smelled, or tasted. And their household plumbing, as well as components of the well, can have lead that leaches into the water. And there have been studies in rural areas in the past where, of course, people have to rely on private wells because extending infrastructure to houses that are spaced very far apart is not practical. But studies in these rural areas have shown generally roughly 20% of tap water in these rural households relying on private wells has lead above that 15 part per billion standard that Adrian talked about. But I'm going to talk about not rural areas. I'm going to talk about a different kind of population that also doesn't have connection to these regulated water systems. And these are peri-urban minority communities. And they exist in many parts of the country. My research has been focusing in on North Carolina. And what you're seeing in this picture here on the right is a map of a small community in green. This community is basically encircled by the city of Raleigh, which is the state capital. And what you can see from this picture, the blue lines are water lines for the city of Raleigh, and they go all around this neighborhood, but don't extend into the neighborhood. So each and every parcel that you see there, these relatively small land parcels, the households rely on private wells for their water. Every backyard has a well. This is an older majority African American community. So I have been looking at these kinds of communities and what the water quality looks like there. And if you go on to the next slide, I began, okay, yeah, so here's an example of another community that I've been working with. It's one of these similar communities near the town of Apex, which is one of the wealthiest suburbs of Raleigh. And what you see in this picture is a gentleman whose community is, again, it's a historically African-American community. It's across the street from that fire hydrant. That fire hydrant marks the end of the town water line. And several houses in this man's community their wells are running dry. One house, in fact, that is visible from, if you stand at that fire hydrant, you can actually see the house that has no water at all. And the residents there are paying $250 every 3 weeks to have water hauled to be stored in a cistern in their basement. So we've tested water quality in these communities, and I'm going to really emphasize that, but it's important to bear in mind that these areas also can have problems with getting enough water. If you go on to the next slide. And what I have found I've been focusing a lot on one particular county in North Carolina. It's Wake County. It's the wealthiest county in the state. It's where the state capital is located. And what this graph is showing is on the horizontal axis is the percentage of the population of given neighborhoods in the county that's African American in peri-urban areas. And on the vertical axis is the proportion of houses in that neighborhood that have a connection to the city water supply. And what you can see is that in these neighborhoods that are either surrounded by city limits or right adjacent to the city but are not incorporated into the cities, the larger the African American population proportion, the less likely are these communities to have a connection to that regulated water utility. I'll add that Raleigh has a really very well-funded, highly performing water utility. But anyway, many of these small neighborhoods are left out and lack connections to these utilities. And as I mentioned, this is a problem elsewhere in the country, not just in North Carolina. If you go on to the next slide. We have been testing water quality, like I said, in these communities. We've looked at lead. And what I'm showing on this graph is what we found is that the prevalence of lead above that 15 part per billion standard is similar in these neighborhoods to what occurred in Flint during the height of the water crisis. So this shows on this chart, the horizontal axis is the percentage of homes that have elevated lead in their water above 15 parts per billion. The red bar is these communities that I've been focused on in Wake County that are basically gerrymandered out of municipal boundaries. And then you'll see the other bars are the 9 wards of Flint, going from the most highly affected ward where during the water crisis, 32% of houses that were tested had lead above 15 parts per billion. And so, like I said, you can think of it almost as it's a Flint inside out situation where in Flint, there was historically white flight out of the city that really decreased the economic base for the city. There are many vacant properties. There's not enough money to maintain the infrastructure. And so the city went bankrupt and switched to a very poor quality water source, didn't provide adequate corrosion control. Here instead, we have these isolated pockets that are surrounded by town boundaries but have never been annexed into the town, and therefore don't get access to municipal services. And so, like I said, it's almost the mirror image of Flint. And I mentioned as well, there are communities like this throughout the South, but also in the Central Valley of California, there are communities in similar situations, largely Latino migrant populations, and similar problems exist along the Texas-Mexico border. And if you go on, I think actually that was all I had to say. But I guess the main point is that these kinds of communities, I would argue, are very under-recognized. These households are at increased risk of exposure to lead in their drinking water, comparable to what occurred in Flint, but nobody's really paying attention. I have research going on right now where we are looking at what are the effects of these exclusionary zoning practices on lead in children's blood. And I didn't want to put this on a slide because it's preliminary data, but we have records of about 35,000 children who were tested for lead in Wake County, North Carolina. And in these communities that don't have water service, they have about a 30% increased chance of a child having elevated blood lead compared to the neighborhoods where people have a connection to a water utility. So we do have evidence. I expect to be publishing those findings within the next several months. But we do have evidence that, again, this exposure really increases the risks to children.
Okay, well, thank you all three of you for your initial presentations. We have about a half an hour here for Q&A, and I'm going to start right off the bat with one relevant to the presentation you just made, Dr. McDonald Gibson. Just a question from Todd Melby at American Public Media, wanting to get clear from one of the photos in your presentation. Are you saying that that fire hydrant that we all saw in a well-off neighborhood, the water line goes up to there, but it does not go across the street to the poorer side of the neighborhood?
Yes, and I will say that this community got in contact with me about a year ago and asked for help to make the case to be connected to the town water supply. And the town has really stepped up, you know, and has been able to get a community development block grant. This is not happening in other places though. And then this community is still, even after they get water service, is going to have the problem of septic problems with their septic systems. There are a lot of overflowing septic systems in the community, and there are no plans as yet to extend sewer service into that neighborhood.
Okay. We have a question here from Nick Gerbis. He's at KJZZ Public Radio News in Arizona, asking, to what extent must states and municipalities follow federal guidelines for lead levels, and to what degree can they set their own standards and policies?
So typically, state or local ordinances or laws will trump if they are more stringent than the federal standard. So California, in most cases, this is being tested right now, so it's hard for me to be as, if you had asked me 2 years ago, I could have told you it always happens that way. But there are some court cases going on now that are testing whether or not states can have stricter standards for, like, the Clean Air Act. But up until now, it has always been that you could have a stricter standard, but you cannot have a lesser standard as a state.
Great. I want to remind reporters here that if you have a question, please type it into the Q&A chat box.
I will also just add, there are no standards at all for private wells, no national standards. Every state sets its own standards, and most states don't really require any well testing. In some cases, they require testing only when the well is newly constructed, but not subsequently. A few states require testing when there's a property transfer. But really, people who rely on private wells basically have to be their own water quality engineers. And most of them are ill-equipped to do so.
I'm going to throw a moderator's question into this before I move on to the next reporter question, but it does raise the question of how does that system that we have in the United States compare to how other developed countries regulate water for substances such as this? Is it unusual to have a system that is so decentralized and largely unregulated, or does the United States stand out?
Are you talking about the well system?
Well, I'm thinking that of the entire network, that there are different rules for different systems, and so much of it seems to be unregulated, including the wells and some of the peri-urban areas that we're talking about here.
Yeah, I can't speak to international practices for regulating private wells. I do know that many European countries provide much higher levels of water treatment than we have in the United States for their community water supplies. Some European countries have nationally owned water systems rather than a network of, individually owned utilities. We have a real patchwork here of ownership types for regulated water utilities. And in some countries, those systems are nationalized.
Thank you. We have a question here from Sierra McCarthy at the Victoria Advocate in Texas. How does the threat of lead compare with other poisons? I live in South Texas, and an unincorporated community in my county has a water system that serves about 800 people that has been shown to be poisoned with arsenic. Wondering how these things compare.
So the arsenic in water can have tremendous health consequences depending on the concentration, and without having that information, it'd be tough to say what exactly is going on there. But again, you know, a child, so let's think of the child's developing brain, developing body is very vulnerable to all of these toxic chemicals. And so not only do they individually affect children, but arsenic is a heavy metal, and lead is a heavy metal, and mercury is a heavy metal, and all of these heavy metals have very similar adverse health effects, and they are cumulative. So again, trying not to put bad things in competition with each other, I mean, it's important to address all of the toxic chemicals that we find in children's environments if we want them to grow up to be smart and strong.
And I would also add that, so arsenic really is a big problem in some areas.
Yeah.
It tends to be, arsenic comes from natural geologic formations usually. There are some other sources as well, but it's usually just from the underlying geology. And so it tends to occur in a patchwork across the nation, whereas lead is really ubiquitous. As Adrian, said, it's used in plumbing fixtures. Until recently, plumbing that was called lead-free could even have up to 8% lead in it. So it's much more ubiquitous. Everybody has plumbing in their house. Everybody has fixtures, whereas arsenic occurs only in areas with basically geologic formations that have arsenic in them.
We have a question from Carol Cruzan Morton, who's a journalist in Oregon, asking, why is filtering water the best solution, as was mentioned earlier? Is it because utilities can't be relied upon to reduce lead in their water systems overall?
Well, there's a lot of variability in water lead levels. So if you're going to go to testing, you just have to know that there's limitations with that. If you're talking about doing something at the lowest cost possible, filters are a good solution. If you'd want to remove the best solution would be to remove all the lead plumbing, but that can be cost prohibitive for a lot of people and for a lot of schools. Also, you have to remove it carefully. So you don't want to remove part of the lead service line that is on your side and not the utility side. And these partial lead service lines can also create hazards. And if that leaded scale gets into the premise plumbing, it can sort of serve as this endogenous source of lead exposure for a long period of time. And so that's why we say filters, primarily because, especially in my research, I reach out to low-income communities. And so that's the most affordable, really, for them.
And when we're talking about filters, are we talking about standard filters that people use for tap water in their fridge, things like Brita filters and so on, or is there something special?
Not all filters are certified to remove lead, so you definitely want to do the NSF.org has really good resources on that. If you look up filters, or pitcher filters, you want to make sure that it has NSF 53 certification on it, and it says it removes lead. So if those have it on the box, then I would feel better about it. If you're talking about refrigerator filters, again, you can look up the type of filter you have on nsf.org's website, and it'll tell you what it's certified to remove.
But they're only as good as they are maintained, right?
Yes.
So the filters do get clogged. I know that happened in Flint just because there was lots of particulates in that water, iron and other things too, not just lead. And they clog the filters. And if you don't change the filters, then then it just goes around the filter. You can also overwhelm the filter if you fill the pitcher too full. So people have to understand, and there's some pretty good videos on YouTube on how to use these water filters properly.
Yeah, I was going to say, I think the jury is a little bit out on how well water filters actually perform over the long term in people's houses. we recently did a systematic review to look for studies that have looked at water filter performance in people's houses. And basically there's none that focus exclusively on lead. So I know, Adrian, you're involved in something now, and you guys may have results coming out soon. But there are concerns as well that water filters, if not properly maintained, that the filter medium can actually serve as a reservoir for growth of bacteria, sometimes harmful bacteria, especially for people who rely on private wells where the water isn't disinfected. So, you know, if people do want to go the filter route, it's very, very important to follow the instructions, you know, have an alert, change the filter medium, you know, according to the manufacturer's instructions. The tests for lead removal are done in laboratories. And so they're not done under conditions of, you know, realistic household use. For people with private wells, there's another option, which is an acid neutralizer, which is the equivalent for a private well owner of you know, basically controlling the corrosivity of the water.
Adrian, did you want to add something there?
No, I know that with regards to testing the water, we are looking at it in high iron locations. That's where we're having the most difficulty, of course. That's where you're going to get a lot of filters clogging. And so we are looking at household chemicals that we can use to try to sediment that iron out. But yeah, one of the big things we do here in New Orleans is teach people how to use filters, how to select filters, and then because they get overwhelmed when they go to the store, and then how to use them properly. That's really important.
Caitlin Coyne at the Charleston Gazette Mail in West Virginia tells us that for water systems that lack record keeping detailing exactly what pipes are made of, which is the case in many Appalachian communities, is there a way to tell how much of the piping is lead and what the effects could be? She says they're often told there that the public service districts only have lead couplings. And even if that's true, does that not present some kind of a risk on its own, and how much of a risk?
Yeah, you can tell. One way is to go under the sink and see what you have. Also, from the extension that leaves the home, you might be able to tell there. Unfortunately, or checking out the meter to see if you can find the pipe that goes into the meter. Unfortunately, a lot of people in New Orleans have to dig down to see if they have a lead service line, and so it can't be 100% perfect. And then some people who don't have a lead service line on their side may have it on the street side, and you can't undo the street. So that's difficult to tell. But there's a lot of videos online. If you rub your key against it and it doesn't shine and it's not magnetic, then you might have a lead line. But definitely go to the YouTube Google, and they'll show you how to identify a lead service line.
Interesting. Another question here, this one from Catalina Jaramillo at WHYY in Philadelphia. Do we have an idea of how much of lead poisoning happens via water versus, for example, paint, which is often mentioned as a #1 source? Paint dust is tested by inspectors. Where does water really fit into the picture?
10 years ago, EPA estimated that about 20% of the average child's blood lead level, or at that time, the average child's blood lead level was about 5 micrograms per deciliter. About 20% of that was probably coming from water, which would have been about 1 microgram per deciliter. Blood lead levels are much lower now in the United States than that, and the average blood lead level of children 1 to 5 in the United States is 0.7 micrograms per deciliter. At those blood lead levels, it's very, very difficult to find a smoking gun. Children are perfectly happy to absorb lead from whatever sources the adults in their lives are dumb enough to put it in. So it's in the water, it's in the soil, it's in the paint, it's in all of these things. So again, we have to try to get away from finding out if it's the water. Well, it was the water on Tuesday, but it was the soil in the backyard on Thursday. So let's take care of all of the sources.
Thanks. Moving on to a question from freelance reporter Deborah Schock in California. says that they have extensive groundwater pollution in some industrial areas, including lead pollution, and some are near areas where groundwater is used for drinking water. Some are more remote. Can you describe the key standards for lead in groundwater, if those exist, and what the risks may be there and what kind of cleanup methods are possible?
Well, I would say that the risk of lead in groundwater is for people who may be drinking well water from one of these unregulated private systems. That would be the main exposure route. I'm not sure if there are specific groundwater standards for lead, but if there were, they'd be tied to drinking water levels. So they'd be tied to whatever is established as its maximum contaminant level. There is no federal maximum contaminant level for lead. Instead, as Adrian mentioned, we have this action level that's really based in part on the feasibility of implementation.
Okay, a question from Paul Schwartz here in Washington, D.C. for Dr. Mary Jean Brown. How do we know what blood lead levels are for children under 1? Is most of their exposure from lead and water? We've just addressed that, but how does the lack of data for this age group impact what we know about blood lead level trends?
So blood lead level in the National Health and Nutrition Examination Survey, which is a population-based survey of the United States, residents in the United States, tests for lead every 2 years. They put their data out. But the children less than 1 are not tested in that survey basically because they're drawing venous samples, and a lot of people would not participate if their child had to be submitted to having venous sample that's younger than 1 year old. I think that what Paul's trying to get to is the idea that for very young children who are being exposed to lead contaminated water and whose primary or only food source is formula that's been mixed with the tap water, that all the things that I just said are off. I mean, then we know that child's not out eating the playground soil, and he's probably not crawling around. If they're 3 or 4 months old, they're not really mobile. So for those children, if there's high lead, which is, if somebody else can talk to the issues around trying to test your tap water at home yourself. But if there's high lead in the water, the utility notifies you of that, then formula should be mixed either using bottled water or another water source, or better yet, breastfeeding, the lead does not cross through breast milk at all easily. And so the recommendation for breastfeeding, which is good for all kinds of other stuff too, is also good to prevent children from having lead exposure.
Great. A question here from Mike Staub at the Associated Press. Can you help us understand how water lead levels translate to blood lead levels? Is there a simple formula? Like, he's making up numbers, he says, but if a child drinks water at 10 ppb for a month, can you expect that to end up, that child to end up having something like, 5 micrograms per deciliter in their blood? Or is there any way to link those two measures?
Oh, go ahead. Yeah.
There are various mathematical models. The EPA uses the integrated uptake, IEUBK model, and it is possible to set the parameters of everything else to 0 and see what you get if you give somebody of a certain age and a certain weight, 10 parts per billion concentration of water, say a liter a day, which is about what the average little kid drinks. I don't know what the outcome is, but I know that child doesn't exist, right? So we don't really know that much about who's getting lead from what source at any given time.
Anyone want to add to that? Okay. Adrian?
Just important to remember that they're all models, and children absorb lead better than adults. That's why we care about them. And it's a model. Models are imperfect.
Got it. Here's a question from Karen Pynchon, who's based in New York, asking, beyond when samples are taken from tap household water when we're measuring for lead, are there other commonly used loopholes that utilities may use to get around mandated lead levels?
Yeah, so the problem in New Orleans is there is no confirmation that the homes that they sampled were actually tier 1. So we're dealing with
And
that.
define tier 1?
Tier 1 would be a high-risk home that has either a lead service line or a copper pipe with lead solder. There just was no confirmation of that. There's also, when you process the sample, if you don't acidify it long enough, you could miss some of the particulate lead that might adhere to the bottle. There are several ways that they use, not just the closed mouth bottle, which forces the person to open the faucet at a slow flow. That could reduce the amount of lead that you're going to capture in that bottle. So all of those things can impact the amount of lead you'll get.
And a question from Alejandra Barunda at National Geographic. What is the status of service line replacement plans nationwide? Is there anywhere that has a particularly good plan for replacement or can be seen as a success story?
Yeah, there are some success stories and they've been written up. You can probably find them online. But I don't know about a national plan. I mean, there has been talk about financing, but right now, I can't speak to that.
I actually think that a big problem really is financing. Replacing lead service lines is very costly, or the equivalent is running water lines connections into the communities I've been studying is costly. And what's happened over the years is that federal funding to support water infrastructure has really declined. In the early 70s, about 60% of the costs of financing water infrastructure came from the federal government, and that level has dropped to about 10%. So the burden really is on the local cities and towns to pay for this infrastructure, particularly for smaller communities. The costs are just really, but they're not affordable. They don't have the economy of scale to spread these costs over a large population. Or if you're talking about a financially stressed city like Flint, they simply don't have funds to pay for these service line replacements.
Ironically, Lansing, Michigan is a success story in terms of lead service line replacement. And it would be an interesting one to look at. One of the things that they did is that they declared the entire lead service line to be owned by the utility for purposes of replacement, which means that the property owners didn't have to replace their piece, the piece after the water meter. And they did have some pretty interesting financing. This was well before Flint.
And so close to Flint. Time for just one or two more questions. Here's one from John Holden. The proposed federal government infrastructure bill, which some of you may be familiar with, earmarks funding for improving water systems, but only in major cities like Chicago, New York, et cetera. But 97% of water supply systems in the US are small or very small systems. Is lead contamination usually an issue in smaller communities? Is this federal plan proportionate to need?
Yeah, I mean, it is a big problem. In Louisiana, we have about 400 rural water systems that are incapable of paying to improve their water quality.
Did you say incapable of paying?
Yeah, they can't afford it.
Right.
And we've been going through some of these communities where there's high iron. We see there's no requirements to use corrosion control. So we also see high lead in several of them. And they're trying to work out a creative way to address the rural communities. But politicians see that, well, you're only dealing with maybe 500 people, 300 people. And so they just have to weigh, how can you have the most impact with the money that you're using? And so they're trying to find ways maybe to merge small utilities that are next to each other, but that's a problem because one utility doesn't want to pick up another one that's having problems. So we're working on it now.
I would agree that not including the very small systems is a huge oversight of that infrastructure bill. They need it even more than the large cities, I would argue. They have the smaller population over which they can spread their costs, and they have the exact same infrastructure problems as the large cities.
Right. So I think a last question here has to do with just how people can know what their situation is in their own home. Are there simple tests that are accurate and reliable that people can do their own home testing and see whether they are at risk?
We're doing a test right now of the test kits that you can buy at Walgreens, Walmart, Home Depot. They're not great, and they're not really good at collecting and detecting particulate lead. And that's maybe the problem if you had lead service lines. The best kind of kit to get would be the ones you mail in. So you get the bottle, you go to Home Depot, get the bottle, you collect the sample, and then you mail it into a lab that does the analysis. That would be the best way.
You can also get testing from your local health department. County health departments offer water testing for lead. These tests aren't cheap. For example, in Wake County, the cost is about $50 to get a test for lead. It includes other metals as well. There are some counties, including Wake, have a sliding scale so that they charge less for families that show financial need.
And that would depend on the state.
Go ahead.
We don't offer parish or county level testing, but your ag center, your extension may have offer testing as well.
Great, thanks. I'm going to squeeze in a quick follow-up question from Mike Staub at AP. If lead lines are being replaced, what is the best material that's being used now to replace them? What's the ideal replacement?
I think that's the $1 million question. We're using plastic, but there are researchers that are bringing up issues about the plastic. So I think that's kind of the $1 million question right now.
Okay, well, thank you all for your contributions today. I want to remind everyone, first of all, that SciLine has a very detailed and succinct fact sheet on lead contamination of drinking water that I encourage you all to check out on our website, sciline.org, under the fact sheets tab. This media briefing, including the video and an annotated transcript, or a time-stamped transcript, will be available on our website probably by Friday. And we encourage you to check that out to review what you've heard here today and to look at some of the previous briefings we've had. And finally, I want to thank you all for just taking advantage of our service here. I hope that those in the reportorial community will continue to follow us at Real SciLine. And until our next briefing, thank you very much and so long.